about k nearest neighbor algorithm. Okay, it's also called KNN, where it's a small k dash ANN or capital KNN. Okay, so called k nearest neighbor. It's a simple algorithm, easy to understand. What does it do? It's used for both classification and regression problem. Okay, if you remember, classification is a classifying between levels, 2, 3 different classes or more, and regression is predicting a continuous value, like how with area the prices of a house increases. Okay, so it's a continuous value in the real space. So see this one thing, how it works. So it's a supervised algorithm. So you have to know some existing classes that, okay, that there are like some negative or red color points, there are some class or blue color point, and there are some percentage or green color points. These are three different classes, okay? And then with respect to the features x1 and x2, so there should be actually three features, x1, x2, x3, but this is difficult to draw on a two-dimensional place. So I tried to show a multi-class classification in a two-dimensional space. Okay, so remember that there should be three features when there are three classes, but I have tried to show three classes to explain the idea of KNN in a two-dimensional space. So now let's say this question mark is a new data item, and we do not know which class it should be classified. Okay, so KNN algorithm can do that. How KNN algorithm does that? It first selects a k value. K is a variable. Okay, it's a parameter of the algorithm. So you have to choose which k is good. So let's say here we choose k equal to 3. Okay, if k equal to 3, we find out from this point what are the nearest three data points and which classes they belong. If we find the nearest, the distance, remember that word nearest, we find here the nearest are all the three green points of the percentage class. Okay, so so this is kind of the maximum number of classes. So it's like a birds of a feather flock together kind of idea. If you see, oh, this is the same color feather, then must be this new bird is also belonging to that group. It's something like that. So if this are all the three nearest, that is k nearest neighbors are of class green, then this question mark point, the new arriving data point, is also class green. Now if it's, we call it a, so that's why we say select the k value, then we find the k nearest neighbors of that question mark point or the new data point. Okay, then predict class levels of the question mark or the new data point based on the most sin levels among the k neighbors. So most sin level here is the green, so we predict, okay, that point is also green. Now what happens if the k value increases? The k value increases, let's say the k equal to 9 now. Okay, then we calculate distance to the others. So let's say there are 5 green points which are in this region closest to that or nearby, but there will be some other like this red point, maybe this red point, also distance wise they are closer, 2 red points, and then 2 blue points will also be close to that. So now you see we cannot call it a majority vote anymore, because majority vote is mostly for for a binary classification where you have more than 50% contribution from one particular class, then we say the majority voting. But here we call it a plurality vote, which means that there are 5, among these 3 classes, the 5 are from one particular class and the rest is contribution of 2 and 2. So this one will still determine the class of the new data point. So here we have to understand that the plurality vote has a this is to show this example. I have taken 3 classes even in a 2D feature space, which is probably algorithmically or mathematically is not correct, but show you the idea that how it works. And then see another important thing here we want to say that depending on the value of k, if the value of k is less than now 12 or 15, so then there will be a chance that although this data point is actually of the green class, if there are more contribution from the blue or the red, there's a chance that this will be misclassified to other classes, blue or red, even though it is actually belonging to the green class, by ground truth I'm saying. So we have to be very careful in selecting the value of k, otherwise there's a high chance of misclassifying levels for our new data point. So now one thing we will tell that we talked about the nearest. Okay, what the nearest means? Nearest is a distance metric. Okay, there are many different distance metrics used for k nearest neighbor algorithm, because the nearest term is important. So computationally there can be many things, like some of the popular metrics. I've listed them. I'll probably not talk through all of them. Euclidean metric, Manhattan metric, cosine distance or cosine similarity metric, Minkowski correlation, chi-square, Mahalanobis, Jaccard. There are so many different types of distance metrics used depending on the data types and many other features. Like, as I said, this k nearest neighbor algorithm can be used for both classification and regression. For classification problems, maybe Euclidean is good. For Manhattan is good. For regression problem, maybe Mahalanobis distance will be better. So what is a Euclidean distance? You are probably aware of it. If there are 2 points in a space, this is the line connecting them, as the crow flies line. Will be calculating the Euclidean distance. So if there are like x1, x2, and x1, y1, and x2, y2, then the distance will be y2 minus y1 square plus x2 minus x1 square. So this will be the Euclidean distance. And so this is like using the Pythagoras theorem, okay? And the Manhattan distance, or the taxi cab distance, or the block distance also called, it's like in this direction, how much you have to go in the x and how much you have to go in the y. So you just add them up and then you get the Manhattan distance, okay? So Minkowski distance is kind of a generalization of the Manhattan distance and the Euclidean distance. So for Minkowski distance, for a particular value of p, which is it will become Manhattan distance, and for a value of p equal to 1, it's Manhattan distance, and p equal to 2, it's a Euclidean distance. So Minkowski distance is a more generalized formation of Manhattan and Euclidean distance combined. And so these are the different distance measure. One more thing, how the regression, how KNN can be used for regression. Okay, so this is a very important part. So like for classification, we see that we go for majority voting or the plurality voting. But for, and then we assign that class level to the new data point. But for, regression, what we do, let's say k equal to 3, and whatever be the values of those data points, we kind of take an average and say, okay, that is the predicted value. Remember, the regression is about predicting a value on a continuous scale. Okay, so what will be the price of the house based on how many bedrooms it have? So if there are 3 houses and we get some information from them and take their average and then predict the result. So KNN will still select the 3 nearest neighbors, get the values from them and calculate the average and say this is the final predicted value. Two things to show you that Minkowski distance is the formula of the Minkowski distance, and when in this formula p equal to 1, this becomes the Manhattan distance formula. Okay, when p equal to 1, if you see that, it becomes the formula of Manhattan distance. And what is Manhattan distance? Once more, this just counts the number of square grids in the x direction and then in the y direction. So this is like 1, 2, 3, 4, 5, 6. This is the distance between these 2 points. By Manhattan distance is 6. But in this Minkowski distance formula, when we replace p equal to 2, then this one becomes the Euclidean distance. Okay, so this becomes 1 over 2, that is square root, and then inside the square. So this becomes the Euclidean distance. Okay, that is this one, y2 minus y1 square plus x2 minus x1 square. So this is this distance, the Euclidean distance. One thing I want to tell that KNN is a lazy learner. Okay, what KNN does is stores all the data points locally in the memory until the actually prediction, the need for a prediction comes. Like prediction means, okay, what is the class level for this data point for a classification problem, or what should be the predicted value for a data point for a regression problem. And until then, it just stores the data locally in the memory. So no training is done. Okay, so the actual real computation occurs when the prediction needs are there. So KNN is also known as an instance-based or memory-based model because it stores all the instances of in the local memory until a real computation is need to be done.